हेलो एवरीवन। अरे ये चश्मा यहाँ क्या कर रहा है? इससे तो मेरे आंखों के पास होना चाहिए। हाँ ठीक है। और ये सिक्का, दिस इज़ अ पार्ट ऑफ टुडेज डिस्कशन, नॉट ऑन दिस सिक्का and this coin, but on quantum computers. So welcome you again to the most mind-bending series of our space science, episode 2, which is on the topic quantum computing. All right. So right now, the device you're watching this on is powerful, right? But there are problems which it can't solve fast enough. Problems we are going to discuss right after this. So, what if we had a completely new kind of a computer? One that uses a strange rule of quantum physics. Today I'll explain what computer computing is. Quantum computing is. Take two. Actually, I said quantum computing, but it's quantum computing in the simplest way possible. So, Joe, it's very hard to say quantum computing. How could anyone leave it? My dead jokes. So, before we jump into the quantum thing, let's understand normal computers. So, the normal computers today we use works on the thing bits. Now you will ask, what are bits? So bits are the smallest piece of data. A bit can be 0 or 1. That is off or on actually. So every song, every picture, every video, or every message you have ever seen in your life is made up of long strings of these zeros and ones. Your computer processes basically these bits using billions of tiny switches called transistors. I know you have already studied about transistors in your class 12th, and if not, do check it out on the Google. So we know about transistors. So it understands what is the string by using transistors basically. The system is great, but there's a limit. For really huge complicated problems, it takes too long. It can take up to millions and millions and millions of years. नाउ इफ़ यू कैन रिमेंबर द सीन, अगर आपने देखी हो, वैसे ही पूछना जायज़ तो नहीं है लेकिन आई अंडरस्टैंड आप सब ने ये देखा होगा। आपने एंड गेम देखी है, एवेंजर्स एंड गेम? तो उसमें आपको डॉक्टर स्ट्रेंज का, डॉक्टर स्ट्रेंज नहीं, क्या नाम था मैं भूल रही हूँ, वेट अ मिनट। हाँ, सॉरी डॉक्टर स्ट्रेंज ही है वो। मैंने इतने दिनों से कुछ देखा नहीं तो सो आई वॉज बिट कन्फ्यूज, बट नाउ आई एम श्योर डॉक्टर स्ट्रेंज ही था वो। सो डॉक्टर स्ट्रेंज ने जब थैनोस मर नहीं रहा था, द थैनोस वाज नॉट डाइंग एंड दे वर कंफ्यूज हाउ टू किल थैनोस, he just went up and thought about every single possibilities, and it took 1 to 2 seconds. He lived that moment, every possibilities he lived there. He felt every, he actually lived that possibilities every single time, and came to the conclusion that yeah, so Thanos will be killed by this chutki which would be done by the great Iron Man. So basically quantum computers works the same way. So quantum computers don't just follow normal rules, they use qubits instead of bits. The huge difference between the normal computers and the quantum computers is that it uses qubits, which means a qubit can be a 0, a 1, or both at the same time. Imagine a coin, okay? If you spin the coin, like, wait a minute, let me do it. If I am able to do it, okay. So it's head, it's tail, it can be both. We don't know. Actually, when we spin a coin, it's both head and it's both head and tails, okay? That means a quantum computer can work on many possibilities at once. The second big difference is entanglement. Like, two qubits can be linked so that changing the one instantly changes the other. Like if we change a qubit, this qubit to 0, and if this one qubit is linked with this qubit, it will also change to 0. So now the both qubits are like connected to each other. If we change one, the other will also change. So it's like a magic, like two qubits can be linked so that changing the one instantly changes the other, even far apart. Like if I have this in India and this one is in US, and if I change it to 0, and if these both are connected, this US wala will also change to 0. So if they are very far apart, like these far apart, more than this, infinitely far apart, if I change this, it will also change. So it's like having two magic dice that always rolls the same number. So why quantum computers are so powerful? In a normal computer, to solve a puzzle, You check each possible answer one by one. But in quantum computers, it works on superposition basically, means you can check many possibilities at the same time. Entanglement allows qubits to work together in a way that's impossible for normal bits. For certain problems can make quantum computers exponentially faster. Now, what could we do with this much power? Like, this is huge. Like, they are too connected, and if we change this, we can change this, and also it's too fast. And this is basically working on as many possibilities you want. So, what's the basic use of this? So you can find new inventions very faster, like new drugs for medicine, like breaking some passwords, or making the passwords which are unbreakable ones. So, like, if you're using Google Maps and you are also using quantum computers, it will find out the most suitable, the most shortest, the most less time consuming way to your destination. And also we can use it in climate modeling, and it can tell us which climate is going, which what kind of weather it will be in the noon. So, but as we know, like a coin, it has two faces. One has good and other has bad. So, here's the truth many don't know. Quantum computers are not better at everything. They won't replace your phone or your PC, but they're more like special tool, a microscope to the new world, which is amazing in certain tasks but unnecessary for others. Right now, companies like Google, IBM, and startups around the world have built early quantum computers that can handle only small qubits, and they need the most important thing, a very cool environment to work. We are in early days. Like, think of it. It's 1950s, and we get the first generation of computers, the classical computer. It's like that. The quantum computers is like classical computers in 1950s. The potential is huge, but we are still a long way to go before they are in everyday use. Quantum computing is like opening a door to a new way of thinking about information. It combines computer science and quantum physics, two of the most mind-bending fields. We are still figuring out the possibilities, but the journey has already begun. If you enjoyed learning about this, hit the like button, subscribe, and share this with a friend who loves science. And tell me in the comments, if you had a quantum computer, what problem would you have solved first? So, if I have had a quantum computer, I definitely had made a time machine, or find a ways to travel back in time. So, you if you like the videos, you can like my if you like this video, do like this video and let's meet in another video. So till then, bye bye.